Hello guys, welcome back to one more video. So as you can see, I have in my table a customized 24 volt DC 4 ampere 100 watts RO water purifier power supply. So this is completely custom made by RF Technologies, and this power supply is capable enough to deliver 24 volts DC with a current capacity of 4 amperes, which is equivalent to 100 watts. Generally, the RO purifiers has a consumption of almost around 3 amperes in a constant run of the pump, along with the UV lights, along with the different kind of alkaline membranes and different type of electronic circuitry. Along with that, the most important thing in RO purifiers is how we should protect it, because we all know that in RO purification, this pump and the electronic circuitry is very important. Without these electronic circuitry, it is impossible for the RO water purifier to function. So now let's talk about different type of negative aspects of the RO water purification system. So different type of negative things which can damage your water purification system is like, for example, like we have a membrane in RO water purification system. The membrane simply clear out different kind of sediments, components, minerals from the water. So it is a very thin membrane. It doesn't have pores, so there are very minute pores. So how it works is like the water pump creates a high pressure and the water passes through the membrane and it gets purified. So that is how it operates. So for example, let me give you a scenario. For example, you are using RO water purification system for almost around 2-3 years. Definitely, like, there is a high probability that your membrane will be jammed. The small pores within the membrane will be filled up with sediments, and it will create an indirect load on the pump. As soon as you create indirect load on the pump, definitely like the pump will start draining more current, it will heat up and it will blow away. It will not only blow away the pump, but as soon as it starts taking more current, it will create damage to the power supply as well. So we need to have a protection there, so that as soon as it takes huge current, the power supply should trip. Secondly, these days, like in monsoons or like different type of electrical failures, we see like in Indian homes we get high voltages. So we should have a provision to protect this power supply from high voltages, so that this power supply again has. Secondly is like, for example, if the RO interrupts with a short circuit, for example, it is a water based device, some leakage can happen, short circuit can happen, then definitely again the short circuit protection should also be present over here. So be it input over current or be it output over current, this device protects it. Secondly, these days, like all the adapters or like the power supplies are completely fitted inside the RO unit in a black box or a plastic box, but it doesn't have any kind of a ventilation, which means like the water vapors with temperature, because like these days summers are there, so definitely inside the cabinet a humid atmosphere is there, and like the humid atmosphere, it is very hazardous for electronic instruments, because like it damages the electronic instruments. We all know, like with onset of moisture, it makes or ionizes the air in between if you have a voltage, and definitely short circuit, different type of arcs, corrosion, different type of damages can happen to the electronic circuits. So again, that is a very important for us to have a ventilation which can remove the humid air from there and keep the dry air in place. So now let me give you a brief about this device which has been made. So as you can see, like all the facilities of this device have been mentioned over here. So it can operate from 180 to 240 volts. So be it a low voltage, be it a high voltage, this power supply is capable enough to handle the power fluctuations. Secondly, it will deliver you 24 volt DC 4 amperes. Our RO consumes 2.5 to 3 amperes, but this has 1 ampere in excess. So for example, if you have different kind of other accessories connected to your water purifier, that will also operate, be it like copper filtering, be it alkaline filter, be it anything. So it is capable enough to deliver you 1 more ampere, which is in excess. Secondly, we have 2 different wires. This is the output wire, which will give you like 24 volt output DC. It has been clearly mentioned, like the black pair is 220 volt AC input. So you need to connect line and neutral to this black pair, and like the green is 24 volt and the black is the ground. So we have 2 different set of wires, the output DC and the input AC. And it has an input high voltage protection using a MOV circuitry. It has an input over current protection. So we have directly input fuse over here, so which has a 2 ampere fuse inside this one. So if there is an overcurrent in your input, the fuse will blow away. Similarly, you have an output overcurrent protection. So in output, there is again a fuse that you can see. So as soon as the output is overcurrent, the fuse will blow away. It has an active fan over here for the heat dissipation and the humid atmosphere control. So this fan will start rotating and it will throw away the humid air and it will keep the entire device dry. And this entire enclosure has been built in so ventilated way that it will never capture humidity and moisture. So it has a thorough gap across the entire device, and the air would be thrown out from here. It will pull in the air from here. It will cool up the device. It will remove the moisture and throw away the air from this vent. So this is how this entire device operates. And it has been very clearly written in detail. This input fuse for the 220 volt AC is of 2 amperes. So if you just open it up, you get to see the fuse over here. This is of 2 amperes. So if the fuse is blown away, you just need to replace the fuse. That's it, hassle free. Similarly, we have an output fuse over here that is also clearly written, and this is of 6 amperes, just because the 4 amperes is the power supply, and whenever the motor starts up, it drains high current. Initially, the spike of the current goes up to 6 amperes. So we have provided 6 amperes of fuse. So you can just remove this fuse as well, and you can replace the fuse for the 6 amperes. So again, I'll fit in the fuse. Okay, so before that, just have a close look on how the device looks. So now this device is like how it looks from externally, but until unless I taste it, like how much effective this power supply is and what is the load bearing capacity, definitely this is useless in nature. So I will now test it using an electronic load tester, which I have, and show you practically that how this device is capable enough to handle loads and how effectively it regulates the voltage ups and downs, and how it keeps the voltage constant so that your RO is never damaged. So this is my power supply. This is my electronic load tester. This is my electronic load tester adapter, and I have a screwdriver. So now let's connect it. So very simple, we need to just open up the adapter. As I showed you, so it has a input power over here, so you need to connect to the input. So I just inserted it. Now this adapter will go to 220 volt AC using the plug, so that this device is powered on. So now I'll just connect it to my AC extension board, So I connected it. Now I will power it on. You see, with a welcome note, you can see the panel has appeared. Now I will show you how to test. Similarly, this power supply unit, as I told you, so this has two terminals. One is black, the 220 volt AC, and another is green and black, the 24 volt DC. So the first step, I need to connect the 24 volts DC to my load tester. So as I have told, this load tester has two terminals. This is the positive one, this is the negative one. My green is positive, so I will connect the green terminal over here. And the black is a ground one, or the negative terminal. I will connect it to my load tester. So now this SMPS will deliver 24 volts to this electronic load tester, and this electronic load tester will generate load so that it drains current from this particular power supply, and we will see what is the capacity of this power supply to deliver the current. And this is the current panel that you can see. So if I long press it, it will calibrate to all zeros, as you can see clearly. So the voltage is 0 just because my power supply isn't turned on. The current is also 0. The coarse and fine tunings have been bottomed down, and like this is the entire display that we have. I'll untwist this one and connect it again to my extension power board so that this particular power supply starts up. So I will now plug it in. So let's plug it in. So as you see, the fan has started rotating, and you get to see 24.9 volts accurately, and this is a stable voltage that we get. So now let's see, with increase of current, does my voltage drop or not? So I will slowly increase the current. So as you see, right now it's taking almost around 1 amperes of current, and if I increase it, it's increasing, but you see the voltage is constant, 24.9 volts. So that clearly signifies how stable this power supply is. Now this electronic load tester, as you can see, has already started dissipating heat. So this LEDs have turned on, and the LEDs over here has also turned on, and the fan has started rotating. So if we slowly increase the load, let's see, let's go to 1.5 amperes. It's still 24.8 and 9 volts. So it's still stable. Let's increase it up to 2 amperes or 2.5 amperes. It's 24.7 volts. It's just a drop of 0.2 volts. Let's increase it further. So now I have near to 3.4 amperes, and still it's 24.7 volts. And you can see it's 84 watts consuming. If I increase it further, let's go to 4 amperes. It's still 24.6 with a 4 amperes of load and 99.95 watts. So it's 100 watts. Literally, this power supply is capable enough to deliver 100 watts. So this, how robust this power supply is, you can clearly understand. If I increase it further, so 4.64, still it's 24. So this power supply has designed in such a robust manner that it will never let your appliances down, but it will protect it completely. Either if you increase the load or the current, the fuse will blow away, but your device will never get damaged. So this is the power of RF technologies, that we develop and innovate new products. This power supply that we have built is very robust in nature and can be used in any kind of RO water purification system at home, and it will save ample amount of money with different type of damages with the power supply, RO system, pumps and motors. So now I will show you like what's inside this one, this robust power supply. Definitely you guys will be curious to know like how this power supply has been built and what's inside it. So I'll just give you a brief look. Definitely I'm not gonna disclose it, but yes, how. And we have used good quality materials, good quality PCB, good quality of wires, good quality of fan. So definitely this power supply will never let your appliances down. So now let's open it up and show you how it looks from inside. So I have just removed the front panel, and as you can see, the fan is rotating and this entire PCB and the circuit looks like this. And we have R-Wave technologies making these kind of innovations for our day-to-day lives. Thanks for watching the video. Bye bye.